Here we're going to look at topic 84, example 3, use an inverse variation model. So there, we're told on a guitar the string length S varies inversely with the frequency F of its vibrations. The frequency of a 26-inch E string is 329.63 cycles per second. What is the frequency when the string length is 13 inches? So normally we say that X varies inversely with Y. So this time we're saying that S varies inversely with F. Okay, we have the string length and the frequency. So S is equal to the string length, and F represents our frequency. Okay, so we have our variables defined, so we're going to use an inverse variation model. Normally we would say that Y is equal to K over X, but we're going to replace X with S. So we're going to say K over S, and the Y value we're going to use as F. That's going to be our frequency. If you were to swap F and S, you would wind up with the same thing if you solved it and you're just careful with your substitution. So in this problem, we are told the frequency of a 26-inch E string is 329.63 cycles per second. So the frequency, actually, let me highlight that instead. So the frequency is that, and the 26 inches is the string length. Okay, so be careful with which number you plug in where. So our frequency is 329.63, and that is equal to K over 13. All right, so let's multiply those out. So we want to solve for K. So 329.63 times 13 is going to be equal to 4,285.19. I typed that incorrectly? No, I typed in something wrong here. Oh, I'm getting ahead of myself. It should not be a 13 here. I made a mistake. I'm solving the problem. That should be a 26. All right, so it's a 26-inch E string. Apologies for that. So let's try that again. 329.63 times 26. That makes more sense. 8,570.38. So my inverse variation function would be F is equal to 8,570.38 over S. Now we want to solve for what is the frequency when the string length is 13 inches. So we're solving for F when S is equal to 13. That's where the 13 goes, not in the previous part. So then we would do 8,570.38 divided by 13, and we would get 659.26, and that is cycles per second. So we'll say cycles per second. So everything we did here is the same thing that you did in example 2. Just example 2 didn't have any context. It was just a purely mathematical problem. 84.3, example 3, we have an actual model. We're modeling a real life situation. Okay, so this guitar length, string length, and the vibration from the frequency. That's it. Be careful substituting, but if you're careful substituting, even if you swapped S and F in this problem, you would still wind up with the same solution. Okay. Don't make the mistake that I made and plug in the wrong number to start and solve for K. So do be careful with that.